if you recall from Wednesday, so maybe here's a relevant announcement. The normal office hour this afternoon is going to happen. I was not allowed to pick up the dog. In the sense that like there was wasn't a relevant person there to do paperwork. I will be picking up the dog this weekend. So, let's talk about what we got last time. And I guess maybe I shouldn't have this projected if I want to like make you guys remember things, even though they are written down in front of you. Let's just recall some of the identities we got last time and where they came from. If you add multiple of 2 pi to an angle, what happens to cosine? What? Stays cosine. I don't want to say like it becomes positive because maybe it was negative. It's just still the same. What about sine?
Sine minus sine theta.
No, it stays the same when you add multiple of 2 pi. Because what? Yeah, you thought. Okay, sorry, I was going. Yeah. Why though? So what happens to an angle when you add a multiple of 2 pi to it?
Just a complete circle.
You add some more full revolutions. Those don't change the point where you land. Add some full revolutions, you don't change the value at the end. What about cosine of minus theta? What is that? Possibly by looking at your notes from Wednesday.
Just cosine.
It stays cosine. What about the sine of negative theta? And what was the reason that happened? When you replace an angle by negative that same angle, what symmetry of the plane happens?
It's a reflection of the y-axis.
You reflect over the y-axis. Cosine of pi minus theta.
Negative cosine.
Negative the cosine of theta. Sine of pi minus theta.
So sine
Why?
reflection of the x-axis.
Yeah, this manipulation corresponds to a reflection over the x-axis. Cosine of pi plus theta. We did make it to this one. I don't think we took the time to write it on the front page, but we did make it to that point in the notes. I'm pretty sure it is negative the cosine of theta. Well, I guess equal signs are important to have. What about the sine of pi plus theta? Negative sine. And I think we gave 2 arguments for that, one of which was like algebraic, but let's think about the geometric one. What symmetry of the plane did we use? Yeah, we reflected over the origin. Which changes y values to negative what they used to be, and changes x values to the negative of what they used to be. Nice. So I think the right thing to do is first let's actually take a moment to put that in. Cosine of pi plus theta is the same thing as negative cosine theta. Sine of pi plus theta is the same thing as negative the sine of theta. And let's use this to fill in the rest of this unit circle. So let's see, that angle of 5 pi over 6, that looks like it's pi minus a little bit, right? So you can get that by going all the way over by pi and then back by pi over 6. So which angle in the first quadrant should that be related to?
Same as pi over 6, or just
Should have something to do with this, except reflected over the y-axis. So the x-coordinate should be negative, otherwise it should be the same value. X-coordinate is negative, negative root 3 over 2. Y value is the same, 1/2. an angle of 3 pi over 4 should be similar to an angle of pi over 4, but reflected over the y-axis. Negative root 2 over 2, root 2 over 2, negative 1/2 root 3 over 2. And now maybe I'll even just let you guys say what the remaining values should be. So what is the point associated to an angle of 7 pi over 6? And maybe this isn't necessarily the only way to see it, but that's the same as this angle, but reflected over the origin. An angle of 5 pi over 4 gives you the point. Negative root 2 over 2, comma, negative root 2 over 2. An angle of 4 pi over 3 gives you cool. And for a while, those will be the extent of the direct computations we'll be able to do. Closer to the end of the semester, we'll develop some new tools which will let us compute things like trig functions at pi over 8 or pi over 12 or multiples of pi over 24. There will be some angles which the techniques in this class just won't ever directly apply to. And in fact, for the same reason as there are degree 5 polynomials which have no algebraic solutions, there are also just angles that you can't evaluate using any of the algebraic techniques that we'll develop in this class. Cool, so let's pick up from there. So by my recollection, at the end of the previous time period, we had evaluated cosine and sine at pi plus 1/2. If we know what cosine and sine are, we can probably figure out what happens to the other trig functions. Secant, cosecant, tangent, cotangent. And let's see. Maybe as well, I'll give you guys one of two options. Would you guys like to go through one of the direct computations first, or would you rather have me talk through a computation? Some people want me to be quiet for a little bit and just go through a computation. Some people want me to talk through. Okay. Those of you who would prefer not to listen, figure out what the cosine of pi plus theta is. I will go through the computation for secant. So let's try to compute secant of pi plus theta. And we've gone through an argument like this a few times. So step one is try to rewrite it in terms of sine and cosine, because we know what sine and cosine do. What is secant in terms of sine or cosine?
1 over cosine.
1 over cosine. Secant is 1 over cosine. So secant of pi plus theta is 1 over cosine of pi plus theta. Right? All I've done is I've taken the formula for secant, I plugged in pi plus theta. But what is the cosine of pi plus theta? Negative cosine theta. So that denominator just gets a negative sign in front of it. 1 over negative cosine theta. And that negative sign, of course, right? If the whole denominator is negative, you can just make the whole fraction negative, right? That's the same thing. So that's the same thing as negative 1 over cosine theta. But what is negative 1 over cosine theta? Cool. So when you change an angle by adding pi to it, you get a negative in front of the secant. Wow. So how many people in that same time figured out the resolution for cotangent? Cool. What is cotangent of pi plus theta? Cool. It didn't change. It continues to be cotangent of theta. So what do you think will wind up happening? Let's just get intuition. What do you think will wind up happening to cosecant? What do you think cosecant of pi plus theta should be? Negative cosecant theta? For the reason that cosecant is 1 over sine, and doing that manipulation to sine just sticks a negative sign in front of it. So that's negative cosecant theta. What do you think should happen to tangent? It's going to stay the same. But I think I actually want to go through it because it stays the same for an interesting kind of reason. The same reason as cotangent, for those of you who did the walk for cotangent. So let's talk through it. Let's try to compute the tangent of pi plus theta Gesundheit. So, you know what I'm going to say. What is tangent in terms of sine and cosine?
Sine over cosine.
Sine over cosine. So the tangent of pi plus theta is the same thing as sine of pi plus theta divided by the cosine of pi plus theta. And what happens to sine when you replace the angle with pi plus that angle?
Makes it negative.
Makes it negative. What about with cosine?
Also makes it negative.
Also makes it negative. So that is the same as negative sine theta divided by negative cosine theta. Do those negative signs cancel? Leaving you with just sine over cosine, also known as tangent of theta. Cool. Let's use this same trick to play this move information around game again. Well, Carl, tell me, what is the cosine of pi over 8? It was one of the things that we just stated last time without explaining why, but it's written down, yeah.
So 2 plus square root 2 over 2.
Almost.
And then big square root.
Yeah, big square root in the top, 2 plus root 2, all over 2. What about sine of pi over 8? Do you remember what that is?
It's the same, just with the negative.
Yeah, with a negative there. So it's big square root 2 minus root 2, all over 2. Let's try to compute some things. And there's even some like guidance there in terms of how to do it. So let's suppose you wanted to compute the cosine of 7 pi over 8. So notice 7 pi over 8 is the same as pi minus pi over 8. Right, that's true, right? Because pi is 8 pi over 8. Do we have a formula that tells us what happens when you do pi minus an angle? Yeah, I guess it's even like written down, right? What's the cosine of pi minus an angle? Negative cosine of that angle. So this will be negative the cosine of pi over 8. And we know what the cosine of pi over 8 is. So that'll be negative square root 2 plus square root 2 all over 2. So here I think is what I want you guys to do now. I think I will have, so 2 and 3 I'll have you guys do. This half of the room I will have you do computation 2. Compute the sine of 7 pi over 8, which maybe you've already done. Compute the cosine of 9 pi over 8. The main takeaway here isn't going to be, do you know what the answer is, but do you know how to use these trig identities? And as you complete one of the items, go ahead and compare what your resolution is with someone around you. Once you're convinced it's correct, we'll maybe talk through it, or maybe we'll just state the answer. get groups assigned. And if I fail to account for a group suggestion that you made, you can shoot me an email and I'll build them back up. If you've already emailed me, don't email me again. Like, should have been one. I wrote down one. Cool. What's the sine of 7 pi over 8?
Positive root 2 minus root 2 over 2.
Yeah. The same as just sine of pi over 8 was? Does anyone want to talk through that one? Okay, let's talk through it. So the sine of 7 pi over 8, that's the same as the sine of pi minus pi over 8. You look for a multiple of pi that's pretty close to the angle you want, and then you figure out how far you're off. What happens to sine when you do pi minus an angle? What's the sine of pi minus theta? It stays positive if it happens to already be positive, which I guess it is. Right, this happens. So this is the same thing as the sine of pi over 8. Is the sine of pi over 8 written down somewhere above as being exactly the thing that we said the answer is? Yeah. So how does this computation work? You know what a trig function is. If someone gives you some angle that's, say, not in quadrant 1, figure out how to use these manipulations to get it into quadrant 1. Once it's in quadrant 1, maybe it's a number that you just know. The next one. What is the cosine of 9 pi over 8?
Negative big square root 2 plus square root 2 all.
Nice. Anyone want that one talked through? Yeah. Question, or you want me to talk through it? Okay, let's talk it through. So, first things first, 9 pi over 8, is that the same thing as pi plus pi over 8? Yeah. All right, so how do you come up with that? Well, you say 9 pi over 8, it's pretty close to pi. That's what you would get if you like rounded it to the nearest pi. And then figure out how far you're off. You're off by a pi over 8. What is cosine of pi plus theta? It's negative what the cosine of theta was. So the cosine of pi plus pi over 8 should be the same thing as negative the cosine of pi over 8. So it should be a negative sign out front, and then I should just get the cosine of pi over 8. Is the cosine of pi over 8 equal to the square root of 2 plus the square root of 2 all over 2? So there's the argument for that. And let's just talk through the sine one again. Sine of 9 pi over 8, first things first. Figure out a multiple of pi that's pretty close to 9 pi over 8. Well, that's pi. Pi is pretty close to 9 pi over 8. But you need an extra pi over 8 to get there. So sine of 9 pi over 8 should be the same as sine of pi plus pi over 8. What happens to sine when you replace the angle by pi plus that angle? It should become negative by this rule. So that'll be negative sine of pi over 8. Do I know what the sine of pi over 8 is? Yeah. So I'll just keep that negative sign around. So this negative is the same as that negative. Square root 2 minus square root 2 all over 2. People feel pretty good about that? Any questions? Cool. So let's get the last couple identities done. And I only wrote this next one on the board for two reasons. One is I was out of space. And the other is the reason that I'll give for the last one will be either algebraic or geometric, depending on what people want to see. So let's try to figure out an angle of cosine of pi over 2 minus theta. So let's draw a picture. So let's see. Here's an angle of theta. If I want to know what happens for an angle of pi over 2 minus theta. Let's see, what does an angle of pi over 2 correspond to? That's a 90-degree angle. It's a right angle. So in order to understand pi over 2 minus theta, first rotate up by a right angle. So there's pi over 2. And then rotate backwards by theta. So now that we have that in mind, focus in on just those red lines and those blue arcs. How are those two things related? How would you go from this line to that line?
Switch the x and y.
You can switch the x and y coordinates because you're reflecting over the line y equals x. So I'll write both of those things down. So reflection over the line y equals x, which is the same as swapping x and y coordinates. Yeah. Nice. So let's use this rationale to figure everything out. So the cosine of pi over 2 minus theta, that's the new x coordinate. How should the new x coordinate be related to the old x and y coordinate?
Why old?
It should be the old y coordinate because, as you told me, this is just going to swap the x and y coordinates. So the new x coordinate will be the old y coordinate. Similarly, the new y coordinate will be the old x coordinate. But what is the old y coordinate? It's just the sine of theta. What's the old x coordinate? Cosine theta. So that tells us something. That tells us cosine of pi over 2 minus theta is the exact same as the sine of theta. Sine of pi over 2 minus theta is the same thing as the cosine. And let's even jot down the reason. So how did we get from one of those angles to the other? We reflected over the line y equals x. Which swaps x and y coordinates. I know I'm standing in front of what I'm writing, but I'll step away in a moment. Swaps should only have one key, right? Yeah. Nice. So, well, you have an idea what I'm about to do. I'm about to go through the same argument for what happens to the other trig functions. So cosine of pi over 2 minus theta becomes sine theta. Sine of pi over 2 minus theta becomes cosine theta. Ooh, I better put that on my cover page too. Cosine becomes sine. Sine becomes cosine. Let's just see if people have any intuition automatically. What do you think should happen to secant? Become cosecant. And secant and cosecant I care less about, so I'll give you guys a choice. Do people want to see the analysis for secant or cosecant walk through it? Oh, secant and cosecant are just going to swap. Secant of pi over 2 plus theta is exactly cosecant of theta. Cosecant of pi over 2 minus theta is exactly the secant of theta. And either way, I'm going to talk through one of them. Well, what do you think should happen to tangent and cotangent? Let's think about tangent for a second. Does anyone have any intuition for what should happen to tangent?
Should be cotangent for tangent, and cotangent is tangent theta.
Yeah, like they should swap. And I think let's talk it through this time. Yeah, let's do it this time not by breaking it down into sine and cosine, but let's try to compute tangent of pi over 2 minus theta in terms of x's and y's. Right, so if you rotate by an angle and you land at some point x, y, then what's the formula for tangent? It's y over x. So this will be the new y coordinate divided by the new x coordinate. But what is the new y coordinate in terms of the old coordinates? X old. They flip. Yeah. So that'll be x old divided by y old. But what trig function gives you x divided by y? Cotangent. Yeah. So tangent of pi over 2 minus theta is the same thing as cotangent theta. Similarly, the cotangent of pi over 2 minus theta is the same thing as the tangent of theta. Nice. Let's go back to thinking about this angle of pi over 8. I think my intent is I'm going to talk through the first one, and then I'll give you guys a little bit of time to meditate on the second item in this list. So let's try to compute the cosine of 3 pi over 8. And here's the mindset I'll take. 3 pi over 8 is pretty close to pi over 2, right? We're only off by a pi over 8. So 3 pi over 8 is the same thing as pi over 2 minus pi over 8. Do we have a formula for what happens to cosine when I do pi over 2 minus an angle? Yeah, what happens to it? It becomes sine. So the cosine of pi over 2 minus pi over 8 should be the same thing as the sine of pi over 8. Is the sine of pi over 8 a number that we know? Mm-hmm. What is the sine of pi over 8? Nice. I guess no is a strong word, right? I think the usual epistemological definition of knowledge is a well-founded true belief. And is it well-founded if the only reason you believe it because I told you it's true? Yeah. Nice. So what do you guys think? Are you guys capable of computing the sine of 3 pi over 8? I think I'll give you guys just a few minutes. Probably not even very many. Do. So what are people getting for this? And why is that? What is the intervening step? What is cosine of pi over 2 minus pi over 8 the same as? Oh, that's interesting. That's what people were muttering about. Yeah. All right, if you don't change the angle, you obviously shouldn't change the trig function. Right, now that I'm going to change the angle, the trig function will change to the cosine of pi over 8. Nice.
Isn't there supposed to be a negative in front of that? Or am I?
Is there supposed to be?
Yeah.
Well, so let's forget all about the reasoning. Let's do it by drawing a picture, by thinking about what quadrant this angle will live in. So let's see. Like, how do you figure out quadrants? You figure out like what multiples of pi over 2 this thing lives between. So let's just go through them one at a time. Is 3 pi over 8 between 0 and pi over 2?
No.
Oh, it is, right?
Yeah.
So it better be in quadrant 1. So should it be positive or negative? Better be positive. So, yeah, and in fact, the identity that was being used was exactly this one, which doesn't introduce a negative sign. We're about to do one last manipulation, which will introduce a negative sign, and will be something similar to this. Let's try to understand what trig functions do when you add a pi over 2 to them. And I have two different arguments prepared in these notes. One of them is algebraic, the other is geometric. I think that I do actually want to go through both of them. I have enough time. Would people rather see the algebra first or the geometry? Would people rather see the algebra again first? Would people rather see the geometric one first? All right. Well, landslide turnout of 2-0. Yeah, let's just follow the process that's in the notes. No need to go out of order. So here's the idea that I'll think of. I'll think of how can I do pi over 2 plus theta in terms of things that I already know how to understand. So how can I get pi over 2 plus theta using the things in this list? Well, I know how to do pi over 2 minus theta. But I also know how to stick a negative sign in front of the theta. So pi over 2 plus theta, that's the same thing as pi over 2 minus theta. And this is a little bit similar to something we did last time. So if I want to compute the cosine of pi over 2 plus theta, let's think about it as the cosine of pi over 2 minus theta. And for now, I'll put that minus theta just in a red box to do this next manipulation. So what is the cosine of pi over 2 minus a thing? It's the sine of that thing. So that means that the cosine of pi over 2 minus red box should be the same thing as the sine of the thing that's in the red box. What was the thing in the red box? Negative theta. And now I'll forget the red box, because that red box was just to help me with this manipulation, to make sure I kept track of exactly what was inside there. What's the sign of negative theta?
Negative sign theta.
Oh, so this was supposed to be like multiple lines that are done all at once. So tell me then, what is the cosine of pi over 2 plus theta? Negative sine theta. Cool, so let's put that on the front page. Cosine of pi over 2 plus theta is the same thing as negative the sine of theta. Nice. This next one, I think I'll let you guys take a moment and figure out by using the same argument. Maybe I'll put the helpful red box right here. I don't know whether you actually find it helpful, but it's there. So do you guys get? What is the sine of pi over 2 plus theta?
Cosine
The same as cosine theta? Do people want me to write the intervening steps? Let's write the intervening steps. So the first thing I see is pi over 2 minus a thing inside of a sine. So I look up here. I see sine of pi over 2 minus a thing is cosine of that thing. So this will become cosine of the thing in a red box. And now I'll remember what the thing in the red box was. What was the thing in the red box? Negative theta. Nice. So now I'll go back to my table of formulas. Do I see something up here that tells me what the cosine of negative theta is? See, this. Cosine of negative theta is the cosine of theta. So that means the sine of pi over 2 plus theta is the same thing as the cosine of theta. So there's the algebraic way to figure out new trig identities from old trig identities. Maybe I'll do it another way by, instead of drawing, like figuring out what algebra to do, let's just draw some pictures. All right, that's what we were doing in the past. And presumably, we can continue to do it.
How come the negative sign doesn't carry over to that last?
How come the negative sign doesn't carry over in this last one?
Yeah.
Cool. So let's instead talk about why the negative sign did carry over in the first one. So what happened in the first one is, so this negative sign was somehow the same as that negative sign. Because whenever you see a negative number inside of the sign, you know the sign is odd by this identity. So you can pull the negative sign up front. But does cosine care if it sees a negative inside of the parentheses? Doesn't. So the negative sign, this negative sign, evaporates in that next step. Cosine doesn't care if what's inside is positive or negative. Good question. So let's see if we can do it geometrically and get the same answer. And I'll do it by thinking about some right triangles. So here are two pictures. One has the angle you need to rotate by in order to get cosine theta, sine theta. The other one has the angle you need to rotate by to get cosine pi plus theta, cosine pi over 2 plus theta, sine of pi over 2 plus theta. So let's just look at these two triangles, which I'll go ahead and draw in blue. What can you tell me about those two triangles? How do they compare?
It rotates 90 degrees.
Yeah, one is the other one just rotated by 90 degrees. So that means all of the side lengths will be the same from one triangle to the next. So that means this length is going to be the same as that length. Those two are the same length. Well, let's think about what those lengths are in either picture. That blue length, what is it in terms of theta? It's the same as the x-coordinate, right? And which trig function gives the x-coordinate? Cosine. So this is exactly the cosine of theta. So this side length is also going to be equal to the cosine of theta. But let's now think in terms of pi over 2 plus theta. This line is now going up and down. It's vertical. So what's the length of that line in terms of pi over 2 plus theta?
Sine theta.
It's sine, not sine of theta, but sine of the new angle. So this is the same thing as the sine of pi over 2 plus theta. But as you told me, these two triangles just differ by a rotation by 90 degrees, or pi over 2 radians. So that vertical line is the same length as the horizontal line. So that tells you that this number, which is that y-coordinate, must be the same as that x-coordinate. So the sine of pi over 2 plus theta is exactly the same as cosine of theta. Does that agree with what we got on the previous page? Let's also figure out what happens to cosine. So let's look in this picture. Cosine is the x-coordinate or the y-coordinate? Well, I guess that's a weird question to answer because it depends on which picture you're looking in. In this picture, if I want the cosine of pi over 2 plus theta, is that the x-coordinate or the y-coordinate? The x, in that picture. So your answer was correct, but to the question that I didn't mean to ask. Which is my fault, I guess. So that length will give me the x-coordinate, but is the x-coordinate positive or negative in that picture? Negative. So that length, right, because lengths can only be positive, that length will be negative the cosine of pi over 2 plus theta. But that length comes from this side rotated. So this side length is the same as that side length. And what is this side length? Positive, but more precisely, which function gives it? Sine. So that tells you that sine of theta is the same thing as cosine of pi over 2 plus theta. And I guess we rearrange some negative signs to get cosine of pi over 2 plus theta is the same as negative the sine of theta. People feel pretty good about that? And you can play this game to figure out all of the trig functions. So cosecant should become the same as the secant of theta. Secant will be the same thing as negative the cosecant of theta. Tangent will become negative cotangent theta. Cotangent will become negative tangent theta. That was fast. Does anyone want me to talk through one of those 4 identities? We've done it enough times that I think we're okay, right? Nice. So with 5 minutes remaining, the content of this back sheet is part of the homework assignment for today. So here's what I want you guys to do, and you have people around you to talk to. So suppose I give you some angle alpha, which lies in quadrant 1, and for which the cosine is 3 things. Compute all of this stuff. And maybe a place to begin is, does anyone want me to recall how to compute sine if you know cosine? Okay. I will, and maybe I'll do it in a slightly different way. Instead of like using sine squared plus cosine squared is equal to 1, I'll draw a right triangle. So let's see, cosine of alpha is 3 over 5. But let's think in terms of SOHCAHTOA. So if I draw a right triangle, and there's alpha, which ratio of side lengths gives me cosine? Adjacent over hypotenuse. So that means adjacent divided by hypotenuse is 3 divided by 5. So right, let's scale it so that it's actually 3 divided by 5. Right, alternately, it could be 3 over 5 and 1. But let's take the simplest picture possible. How do you think you could, what do you think you could do to figure out the side length of the remaining side? Use the Pythagorean theorem. So if there is, I don't know, y, because it's vertical, 3 squared plus y squared is equal to 5 squared. Does that look like you could solve it for y? Yeah, so let's see. Y squared is apparently 25 minus 9, which 25 minus 9 is 16. Is that a perfect square? So what is y? 4. And right, theoretically, you could say, well, it's plus or minus 4, but it's a triangle, so it better be positive. So tell me, what is the sine of alpha? 4 over 5. So maybe I'll also say problems 2 through 9 and 14 and 15, all that you'll need to do to accomplish those is look at the identities on the front page. So I think that I don't want to explicitly talk about those quantities. I'll give you the comment that in the time you have, try to figure out one of the items 10 through 14, because those are the ones you might want to ask me about. Right.
This plus our block.
Mm-hmm.
And then we would use this one. Place that, but we have negative, so then we would just add negative to that, correct?
Mm-hmm. And then I guess right down the final line, so you know what sign of alpha is?
Oh, yeah, okay.
Yeah.
And then it would just be negative.
Yep.
Okay.
And I guess a sanity check you can always make is you can think about what quadrant they should be to decide if positive or negative is correct. Nice. So it's that time. I mean, I'm going to stay here because I have another class that is exactly the same as this class. Happening again. So I guess I can't just let you stay here because most of the seats are taken. And maybe I'll say this too, that group quiz is going to be another one of, I've decided I really like this two-part format. So I'll give like most of it no calculators, and then there will be a short calculator
We
section.
can do a note sheet then again too, right?
Yeah, note sheets allowed. In particular, maybe if a note sheet that has like the units on it and some stuff. Yeah, go ahead and plug in the bonus right now. I'll be standing right here. Bonus stuff? All right. A combination of backbone, I think, is so the do walks away. You can think about the left pi as being like so pi over 2 is a quarter of a revolution. So that's 11 quarters of a revolution. Then you can just count that. On the other hand, if you want to write this as a multiple of 2 pi, plus or minus and stuff, then you know what you can do with multiples of 2 pi. So there's more than one approach. Okay. Yeah. Thanks. And I am going to have my office hour this afternoon, so if you want to swing by and ask me more detailed questions. Okay. Because I kind of gave you a copy of this on that.
He's in on for the show.